Introduction. Plane shapes can only be measured in two directions, breadth and length. They do not have depth or height. They have one flat surface, sides, angles, and vertices. They are called two-dimensional figures, such as square, rectangle, circle, triangle. Three-dimensional shapes have depth. They can be measured in three directions, breadth, length, and height. They have more than one face and many edges. Three-dimensional shapes have many more angles and vertices than two-dimensional shapes, such as cube, cuboid, cylinder, prism, pyramid, etc. Two-dimensional shapes, three-dimensional shapes. Objectives. At the end of this lesson, you'll be able to identify two-dimensional and three-dimensional shapes, recognize different views of 3D objects, locate a place using map, define faces, edges, and vertices of different objects, explain polyhedron and convex polyhedrons, describe prisms, discuss pyramids, apply Euler's formula. Combination of different shapes. Lighthouse surmounted by a hemisphere. Cone surmounted by a hemisphere. The above shapes are a combination of different shapes. We use these shapes in our day-to-day life. Views of 3D shapes. We live in a three-dimensional world. Every object you can see or touch has three dimensions that can be measured by length, width, and height. Example 1. The room you are sitting can be described by three dimensions. The monitor you are looking at has three dimensions. Different views of a dice. Side view, top view, front view. Different views of a car. Side view, top view, front view. Mapping space around us. Usually maps are used to locate a particular place, river, mountain, etc. Map is different from picture. This map is drawn by Radha. In this map, the route from her house to her uncle's house is shown. How far Radha's house from her uncle's house? From this map, it is very difficult to find which place is near from Radha's house. We do not know the distance between circles. So, there is lack of information. We cannot answer to the questions. This map is drawn by Ravi. Ravi uses different symbols for different landmarks. Longer line segments have been drawn for longer distances, and shorter line segments have been drawn for shorter distances. He has drawn the map with a scale. Symbols and mentioning distances has helped us to read the map easily. The actual distance is denoted by 1 centimeter or 1 mm in the map. This means that if one draws map, he/she has to decide that 1 centimeter space in that map shown certain distance, say 1 kilometer or 10 kilometer. This scale will vary for map to map and not within the map. Faces, edges, and vertices. Faces. The polygonal region of any solid is called its faces. Edges. The line segments along which two faces intersect. Vertices. The points at which three or more faces meet. Polyhedron. A three-dimensional shape whose faces are polygon is known as polyhedron. It is derived from Greek word poly means many, hedron means face. So polyhedron is a three-dimensional object with many faces. Example: the faces of cube are squares. The faces of rectangular prism are rectangles. Polyhedrons: triangular prism, cuboid, octahedron. Non-polyhedrons: those solids which have curved surfaces are not polyhedrons. Cylinder, cone, sphere. Convex polyhedrons: if the line segment joining any 2 points on the surface includes faces, vertices and edges of the polyhedron, lies on the surface and does not intersect itself, is called a convex polyhedron. Convex polyhedra: we know that a polygon is called a non-convex polygon if the line segment joining any 2 vertices does not lie on the polygon. Similarly, we can define polyhedron. Given below are few examples for non-convex polyhedron. Non-convex polyhedra: small stellated dodecahedron, great stellated dodecahedron, great isosahedron, great dodecahedron. Regular convex polyhedron: the solids which are convex and whose faces, edges and angles are congruent are called regular convex polygons. Examples of solids which are regular convex polyhedron are tetrahedron, cube, octahedron, dodecahedron and isosahedron. Regular octahedron: an octagon with 8 equilateral triangles as faces. Prism: a prism is a special type of polyhedron. It has 2 ends which is of same shape and size. These ends are parallel to each other and are separated by rectangles. A prism is named according to the base of the prism. For example, the bases of the prism ABCDE and ABCDE are equal polygons which are parallel to each other. The faces are the rectangles AABB, BBCC, CCDD, DDEE and EEAA. AA, BB, CC, etc. are called lateral edges. Prisms are classified according to their bases. Triangular prism: triangular prism is composed of 2 triangular bases and 3 rectangular sides. Pentagonal prism: if the base of the prism is pentagon, then the prism is called pentagonal prism. A prism is called a right prism if the lateral edges are perpendicular to the bases. If they are not, it is called oblique prism. Pyramid: a solid shape with triangular side faces meeting at a common vertex and having polygonal base is called a pyramid. Some pyramids have square bases. Example, Egyptian pyramid. They are called as square pyramid. A triangular pyramid is also known as tetrahedron. Pyramids are classified based on the base of the pyramid. Triangular pyramid, tetrahedron. If the base of the pyramid is triangular in shape, they are called tetrahedron. Square pyramid: if the base of the pyramid is a square, then they are called square pyramid. Hexagonal pyramid: a pyramid has a hexagon as its base. Summary: let us summarize what we have learned. 2-dimensional shapes measured by length and breadth. 3-dimensional shapes measured by length, breadth and height or depth. 3D objects have different views from different position. The line segment along which 2 faces intersect is an edge. The points at which 3 or more faces meet are called vertices. A 3-dimensional figure whose faces are polygons is known as polyhedrons. Both prisms and pyramids are named after its bases. Euler's formula is given by F plus V minus E is equal to 2, where F denotes faces, V denotes vertices and E denotes edges. This relation is true for any polyhedron.